to proceed by like mutating the inputs, and it's guided by code coverage, right? So it's not just blindly making changes; it's making changes to your input and observing that that actually affected hitting a new code path. In which case, it's going to keep sort of going down that path. Or if it's uninteresting, if it's a path that's already seen, it'll just sort of throw that away, keep working. It tends to be very efficient too. So it's going to open up multiple slaves to operate in parallel. And it's going to be able to save its progress to disk. So you can let it run all night. In the morning, you can just kill it, use your machine for the day, and then you can start it up again, and it'll keep on going from where it left off.
So this is a code coverage tool providing randomized testing?
It's not a code coverage tool directly. It uses a code coverage technique to guide its behavior. So it's a testing technique. So what's going to happen, the output of this is going to be inputs that cause your fuzz function to either crash the program, consume a ridiculous amount of memory, or hang for a long period of time.
Yeah, it's very cool.
And so the output of that you can then turn back into unit tests, which you can then fix your code and then know that you didn't break it going forward again. I'm going to do a lot of demos, so maybe be more clear when we get to that point. So step one, you need to install the tool. There are two tools. The first is GoFuzz build. It's listed second, but the first one you're going to be using is GoFuzz build. That's the one that's you're going to give it a path to your package, and it's going to assemble. It's going to basically do the compilation and instrumentation of your code and assemble it in a zip file. It's going to be used in the second tool. The GoFuzz program is the actual runtime, which is going to execute your code and do all of this sort of heavy lifting. Step two, we're going to add a fuzz function. So this is the main entry point for the fuzz testing of your application. It's got a very simple interface here. So it's going to take one argument, which is a slice of bytes, and it's going to return an integer. And there's three values of significance. If you return a 0, it means that you encountered some sort of error. If you return a 1, it means it was successful. And you can optionally return -1, which is sort of like a condition, like, don't ever show me that input again. That was really horrible. You know? I haven't used that one myself yet, but it could be useful. Step 3, we're going to need to generate some initial data corpus for this thing to start with. It doesn't have to be that large, but if you can give it sort of a diverse set of inputs, that maybe helps you get to some interesting outputs sooner. In my experience, I can frequently take the existing unit tests I have, which have like very controlled inputs, and either manually or automatically export those and use that as my starting point. And when we build these, we're going to put those in the directory workdir/corpus. Step 4, we're going to go ahead and build the package. So we're going to use that GoFuzz build command. Use that to, you can give it the one argument, which is the package path, and that's going to build a urapp-fuzz zip file, which you then use for the next step. In step 5, we actually run the GoFuzz program. This is where all of the sort of CPU-intensive work starts to happen. It takes two arguments. -bin is the path to that zip file we just created in step 4, and then -workdir is the path to that work directory, which initially only needs to contain the corpus that we created. So it's not that much work. If there's one takeaway from this, is like you should not be afraid to go home and do this, because it's literally writing like a 5 or 6 line function and running 5 or 6 commands, and you're up and running. So it's very quick and easy to get started. So let's actually go through a quick demo. It's fun, right? That's good.
800 by 600. That is.
We can see that in the back.
Can you still read it now? Yeah? Okay. So actually, that's not how we should start in. So what I did is I created a really contrived function called split space. And keep in mind, I was trying to write a function that would actually exhibit certain errors. And I don't know about you, I tend to write them all the time when I'm not trying, but when I'm actually trying to create errors, it's kind of a pain in the ass to do. So split space is a function which is going to take this slice of bytes coming in, and it's going to return an array of a slice of strings or an error. And the basic behavior I'm trying to capture is if I see a space, I'm going to break those up into separate words. So again, this has some obvious errors in it. Don't get too excited there. On line 6, we basically create the return value. I start looking for a space on line 7. I'm going to have a loop where I'm sort of, every time I find another space, I'm going to break up another word and put it into the array. There's some logic here which is ultimately going to lead to our downfall, which is if we see 2 spaces in a row, we're going to try and not make an empty word out of it. And at the end of the loop, when you get to the last space, there might be a word after that. So here we're trying to make sure we didn't just actually end on a space. We're going through this kind of quick because it's simple. There's obvious bugs in here, but that's okay. It actually works correctly for this very simple test input. So I wrote a test case which just tests, the test input, and of course that's not going to either. So if we run that test, the test passes. We have some sense like this basically works, but we know there's problems, right? So what do we want to do? We want to run some fuzzing testing on it. So here I've written the fuzz function. And as you can see, it's, again, like a 5 or 6 line function. It conforms to the signature I mentioned earlier. It's going to invoke the split space function and pass in that data. If there's an error that happens, it's going to return 0. If there's no error, it's going to return 1. Very simple. One other minor thing to note, because this is a sort of an exported function in your package, if you didn't have this first line, when you build your application, it could be included in the fuzz function as a part of your application, which you probably don't want to do. But if you include this build tag GoFuzz, the GoFuzz tool is going to pass that build tag on automatically and see this function. But when you build your application normal, you're not going to include it in the fuzz function. So it's sort of a simple thing you could overlook, but it's an important thing for your application. So let's go ahead and run it. At this point, actually, we need to build the corpus. I already did that. So if we look in work corpus, there's a single file which I just called A, and I just gave it the input, the test input. Again, it's just raw bytes in that file. The name of the file is insignificant. It's just going to take that content and pass it along. And hopefully not too far in the history. We would run gofuzz build with the path of the package. It's github.com/mshock/fuzzdemo. This can take a long time on your package, depending on how many dependencies you have. It doesn't take too long for this sort of contrived example. And then finally, we would launch it with the gofuzz command. So here again, it's going to take -bin, which is the path of the zip file we just created, and -workdir is the work directory, which right now only contains the corpus. So we'll fire that up and let that run. It's going to spit out some output while it works. It found the problems amazingly quick. So Crashers 2 took about 30 seconds when I ran this earlier today, but it found it like the first couple tries. So slaves 4 tells us there's 4 processes running. As I said, that Crashers. For real applications, that might stay at 0 for a while it's sort of going through your initial data corpus, which presumably works. The coverage number should go up over time. That's, again, it's not a percentage. It's actually a number of entries in a bitmap that have been covered. So, again, it's normal to see that go up over time. And that worked surprisingly fast this time. So it already found the 2 crashers, which I hope are the ones we're looking for. So let's go ahead and take a look. That workdir, when we started, just had the corpus directory, but you notice there's a new folder called crashers now. Let's look at that. So if you notice, there's one, essentially, the hash that you see there is the file name is corresponding to the crash. There's 3 files for each one. The first one with just the hash is the actual binary set of bytes that triggered the crash. The one with the extension .output is going to contain the actual output of the program, so that's going to have like your stack trace in the case of a panic or a hag. And the quoted is also useful. That's the same binary input that caused the crash, but it's in a quoted string with all the appropriate escaping. So if you ever want to take that and then make a unit test, most of the time that's what I'm just copying and pasting from that text file in that quoted. And again, it just sort of closes the loop a lot faster. So let's take a look at the first one real quick. Corpus, yeah, thank you. So let's not look at binary. So this was, let's look at the output first. So we got index out of range. Hoping it found the other one because it was always in the other order last time. So this tells us that, again, if we look, the line we're interested in, split.go line 20. Go back to split.go. Yep. Okay. I might have adjusted the lines somehow. But anyway, it should be on line 18, the one I was noticing earlier. That's the one where there's definitely an index out of range. Again, even an empty string input will, empty string would cause this to crash on line 18 as well. And then the other one should have been a hang. We had a sort of an infinite loop in there. Let's see if that was actually the other one. So I guess it didn't find the other one yet. If we'd let it run longer, it would have found another one. So yeah, we're running short on time now, so we'll just go ahead and start to wrap it up. as you can see, it's very easy to get started. It's found 2 bugs relatively quickly when we just started. Real applications can take a little bit longer, but it's very useful. So just one more conclusion slide. So this has been used successfully to find bugs in the Go standard library. That's pretty awesome. They have a README of trophies. So if you're interested in what kind of bugs have been found using this tool, it's a quite a long list, a growing list of them on the README. That's cool. And you're probably wondering, have they ever tested GoFuzz with GoFuzz? And the answer is yes, of course. They're computer science, so they have. At Couchbase, where I work, we found bugs. We have a query language called Nickel. We found bugs in that query language parser. We have some wire protocol stuff where we're parsing data structures. We found errors in that as well. The search technology I'm working on with Levy, we have a Unicode segmentation library. We use that as a sort of a part of our ongoing testing for that as well. So it's very useful. Like I said, I'm kind of excited about it, mainly because I was kind of skeptical of fuzz testing when I first heard about it. And then I sort of found out how easy it was to get started, and I've been finding bugs with it. So I'm here to sort of spread the word and get everybody else excited about it.
How extensive is Levy project? Is it compared to Lucene? I mean, is it pretty robust, or is it just sort of?
I mean, we're not nearly as feature complete as Lucene, but we're growing. So again, I could give a whole talk on Levy just by itself, but you know, I'm happy to answer any other questions you have offline on that. Any other questions?
Is it useful for anything besides like testing byte array?
So it can be. I think that's an area where they plan on doing some more enhancements. Certainly, if you're a little bit creative, it doesn't have to be just byte arrays. Obviously, if you're working with strings or things, you can massage that. You have other inputs that you could sort of do a little conversion on your own into different structures, and then apply the same sort of behavior. But I think that's an area where it's future development is still an option there.
So if I'm going to test a server, then I would basically take a byte from the request out of it and then push it, right? That's the example, I suppose.
Yeah, I mean, I would think you would probably just test this as like a library. Would be the easiest way to integrate with it.
Okay.
Great, thanks.
Thanks.
All right, so I think we'll do a 5-minute break, and then so a 5-minute break. We'll be back here. This is much longer. Yeah, so 7:28, and we'll get on up with Patrick talking about break.
Right, so but what you're saying, I thought you were saying make the call HTTP call. We wanted to test it and then use a JSON request.
One last thing, sorry. If you haven't signed in, this is perfect time right on the table where the drinks are at. Just sign in, just so I don't get in trouble with the folks upstairs. Thanks.
Yeah, you did drive.
Why are you doing that? And he actually we'll find out about the fact that I used to be at a time span. So that you're not coordinating, you're not talking, and
That's what I remember.
Those are a little harder to
Yeah. Stabilize. It's very manual. Weeks later, you realize there's more hoops on the other side. Yeah. So this isn't it.
We had 2 ways to do
Seems to be a lot of different areas. You really should do that one because errors. I think that makes sense.
So I did one where I sort of another one where I was a little confused. I was like, pretty small. So I was curious. But when I ran it with some of those and then the other thing I found we haven't done any like things that created so if you want to look at it, there's so much stuff here. I can see what it's
We're gonna have to stay we're actively
check it out. Here's architecture. Because my code was already pretty robust. So when I was really starting to do that, mucking with what happens if like you tag away, stuff that I don't have to care about. Because
Alright, so we're gonna get started with the next talk. I did notice that we have these in 2 places, so if you think we're all out, we do have one. But on to our next talk with Patrick. Yeah, thank you. Dave.
I'm Patrick Pigeon. I'm a software engineer at a security company called Farah. Collect data and shove it into business. I mean, they want to give us the voice on top of it for our hands to review the data. So I'm going to talk a bit about database SQL, how to interact with databases and go. Database SQL, the Go standard library provides some stuff for you to use to interact with SQL databases. The docs are pretty decent, but there's a lot of like little subtleties that you have to like read like every single line of every single like function that you're going to use, or else you wouldn't really pick up on them. To fill in the gaps for what the docs don't really provide, there's go-databasesql.org, which has a lot of examples. Very useful for anyone getting started with the database SQL package. So step one, if you're going to use databases in Go, you have to choose a driver. So the standard library does not provide any drivers for you, it just provides a set of interfaces the drivers can implement. Talk to like Postgres or MySQL or SQLite or something like that. So the package here, as an example, is a SQLite driver. And by just importing it and not referencing it, it will go ahead and register itself as the SQLite 3 database driver, the database SQL package. So here's an example of opening up a new in-memory SQLite database, and it gives back this database object, which is a pointer to a SQL.db. One thing that was new to me, I guess, with Go, is that this is not an actual connection to the database. This is more or less a pool, and by opening a connection, not opening a connection, but by creating or opening the database, you aren't actually like touching the database, depending on your driver. So the second line here, ping, will ensure that your pool obtains a connection. And you can actually say, oh, open my database, and here's my login credentials and stuff. And so, okay, cool. You have this like database handle, it's all set up, ready to go. And then the first time you were trying to use it. And to reiterate on that, SQL.db is not a connection to the database. It is a pool. It manages the connections for you. By default, I think it is unbounded with how many connections it tries to grab. So there are functions, set max idle connections and set max open connections, to put upper bounds on them. That's something we care about. So now that you have opened this like handle like pool thing to your database, you want to actually like use it to like make queries and like execute statements. So the three functions that the SQL package provides to you is the exec function, which is simply executing a statement. It's not going to give you back any data. It gives you back a little, but it's not going to return like raw data. I'll give some examples of that. You have the query function. That's your typical like I'm running a select, and then I want to iterate over the rows that come back, do something with it. And finally, there is a query row function, which hides some boilerplate of iterate result set query. The other thing is that your SQL.db handle, you can execute these functions straight off of it. So that's like not in a transaction. What it's going to do, goes to this pool, it grabs a connection for you, and like create a new one. And then it will prepare your statement, execute it. That's about it. So they do have some types. You can explicitly prepare a statement. And what that would do is if you say db.prepare and give you a query, it will go ahead and prepare that statement on a connection, and it keeps track a little bit for you of what connections have what statements already prepared. So if you're really worried about like, I'm going to execute a statement, and the first thing it's going to do under the covers is it's going to prepare the statement, and then later when you execute it, you bind your parameters and stuff in. So that's like if you don't want to make 2 round trips or something, it will go and try to kind of cache the prepared statements to the actual connections for you. You don't have to really worry about that, but it's just something kind of real nice guys. Those big SQL package developers. there's also transactions. So the only way that you can ensure that success calls to exec or query row are executed within the same connection to your database, you have to use a transaction. So you can db.begin, it'll give you back create prepared statements off of your transaction. And that's pretty much the only way that you can ensure that the same connection is going to be used. So if you're setting properties of your connection as part of your query or something, you got to use a transaction. So this is a, just a run-of-the-mill example of using exec. This is executing a statement. We're not querying to get data back. So we have, the schema for a food table here. We have the query, which is to insert a value into the food table. And then down here, we're given our little handle to the database, and we're given a value to insert into there. And we execute it. If you notice in our execute statement, it's saying, okay, the only parameters for this query will be the value column. And then for timestamp, we're just setting to now. But this is SQLite. If you guys aren't familiar with SQLite, if you make an integer primary key, then it's basically like a serial from other databases, so it'll automatically assign it. So earlier I said that exec doesn't return anything. Caveat there is your driver can implement. It's the last insert ID. But let's see here. The result from exec is an interface that you can use to obtain the last insert ID. So in this case, it'll spit back the ID assigned to the row that you just entered. And then there's also another function in the result from exec that you can use to get the number of rows that you modify. That's entirely dependent on your driver and those functions. Moving on. Querying for rows. This is where the kind of like tricks, the gotchas can kind of come out. So, simple enough. I want to select the ID value and timestamp from our food table. The first thing, so assuming that actually prepares and is executed properly. Like one of the first things you always want to do is anytime you successfully execute a query, it's going to return back a rows object, and like those suckers have to be explicitly closed. They do implicitly get closed, and I'll get to that. But if anything goes wrong when you're iterating over the response that comes back, if you have not explicitly closed your return row set, that connection that you've gotten from the pool is never going to be closed. Yes?
So in your query statement there, is that actually doing a prepare and then the query underneath?
Yes.
Okay. So if you don't know and that's in the loop and you're doing that 1,000 times, you're doing actually 2,000.
There are. There is a with the exec function here. I don't know about with. It might be a thing with query, but the exec function will try to promote your database driver to see if it has an exec function, and it'll just so your driver can implement its own exec function, and that indicates to the SQL package that it can basically prepare and execute the statement in one step, so like one round trip. So as a thing, you have to look at the driver, and obviously I haven't looked closely enough to find to tell you what SQLite or Postgres. And it does, after it prepares it, it does keep track of that for you. So it'll keep track of the prepared statements within the same transaction and stuff like that. So if it sees it again, it'll just exit. But yeah, this if anything happens as you're iterating your row set, that connection will never be released, and it's just going to hang out forever, and eventually run out of shared memory or something in your database. So then for the actual iterating of your results, you don't get back an object that is here's your slice of rows or something. You have to call this rows.next function. And what this says is basically if there are rows available for you to scan. So, for rows.next, that's, oh yeah, we got a row here. You come down and you can call the rows.scan. So there's like a stateful kind of interaction here going on for iterating over your result set. Scanning is, like here I have an object that has an ID value. There is a struct that has an ID value and a timestamp property set. And so I can scan basically directly into it. And so what that's saying is the first column of the row that has come back is going to be scanned into the foo.id field. Likewise for the value here, and then also the timestamp. I'll talk about scanning a little bit. Just kind of the caveats around that. And then finally, if you notice, the only thing you get errors for is scanning, but like rows.next can bomb out for any arbitrary reason. Well, if for whatever reason, like the database server shuts down, or you lose your connection, or something bad happens, you check after you've iterated over your row set for errors. So that's kind of the last step is like, everything is going to be closed from your deferred. So if there are errors in this guy, you find out about them by checking the rows.error. If rows.next, if you successfully iterate through all of the rows from the result set, rows.close is automatically called, but it's safe to call multiple times if you want to call it 10 times just to make sure that you really close that. So for scanning, you can scan into a lot of the kind of basic types. So you can scan into strings, ints, floats, byte arrays, bool. You can also scan into pointers to these things. Things like time. Like I have this timestamp thing right here. It's up to your database driver to be able to support like oh, here's some like byte array that I got back from a query, but it's associated with a timestamp with times in a column in the database. So I will create a time object for it, or I will support scanning into a time object. But from all the drivers I've used, I've had no problems at all scanning times. That's most popular MySQL, Postgres, and SQL drivers. Again, your scanning order is dependent on your select order. So if you're doing like select star, like you just have to like look at your DDL to figure out what the column order your table was created with. And lastly, if you're trying to scan something complicated, like maybe you're trying to scan like the Postgres array type or something like that, you can insert, like you can use a dummy SQL.raw bytes value and to get a byte array, and then when you're iterating over your results set, do whatever to actually like turn that into the actual type. So query row can be used to eliminate all of the places that you could go wrong with iterating over the result set from using query, if you just want to like create a single row. So if you're select limiting one, or if you're doing like an insert into a table and returning values from your insert or something like that, you kind of have your just one shot. I'm going to execute this query, I'm going to get back one thing, and database SQL will make sure that the rows are closed and all that stuff. The only method available to you on the result from query row is the scan, which works just like it does when you're scanning on the rows. One difference between query row and query is that the rows scanned here can return typed errors, SQL.error no rows, if you didn't actually row. So while that's probably something you're going to want to actually handle, but it does come back as an error. So that's how you find out if you don't get a response. So that So that right there was like database SQL, and that is everything Go gives you out of the box to query and interact with databases. So it's pretty cool. And really, I used strictly database SQL for probably the first like 6 or 10 months that I was doing database things, and like, it was fine. There weren't really any, aside from kind of the gotchas with making sure that you're closing everything. It worked well. But after a while, you kind of get tired, or at least I got tired. I was like, man, I have these structs, and I'm running these queries, and I really just want to get the data from the query in the struct, and I'm having to write like these scans, and that seems kind of obnoxious. So I started looking around for some of the quality of life stuff. I came from to Go from like Python. So in Python, we have SQL alchemy to an extent. Mango ORM, which is okay for what it is, or it's okay for in the context of all the Django stuff. So I started looking around and like, no, maybe there's like a SQL alchemy equivalent or something like that in Go, and there's not. There are a lot of things claiming to be ORMs, but really they just handle the mapping of your queries to structs. So the object thing and the relational thing is basically like not present, but the mapping is. I did look around the other day because it had been a while since I looked at the ORMs available in Go. Vigo actually has a pretty legit looking, well, I don't know about legit, it looks like it's fairly like, it has a lot of features. It has a lot of features that you would expect from an ORM. Like it can resolve relationships. You can actually model them, which is the first times I've seen that in any Go ORM. And it also has like, the kind of filtered chaining for building up your queries, in addition to some more like SQL style query building. So when I say that, it's like you can say, dot filter like field 1 __ like field 2, and it'll actually traverse through the relationships and build up your queries for you. There's also Gorm, which is the Vigo ORM. You actually have to pull in, I think, all of the Vigo framework if you want to. Gorm is kind of a standalone package, which seemed to be second most feature complete in terms of like full-blown ORMs. It does have support for relations, but its query building syntax is more like directed not to SQL query building, and not necessarily like SQL model-based kind of thing. And then I put Gorp on there because that was the first ORM I ever tried, and it's literally you just set up configuration stuff and map like structs to tables, and it can take care of generating some of your DDL. So like it can generate your table definitions. And I think now it might be able to do some migration stuff. And it, if you want to just like retrieve a struct by an ID or something, like you can do that. You don't have to write code for it. There's also a handful of other like smaller libraries that just help you take care of like mapping. There's some stuff. There's with Postgres. There's something called DAT, which is like the data access toolkit. It has some. It can leverage some of the Postgres stuff to like build up like JSON documents and actually return that from the query, which goes straight into the struct. But there's a lot of kind of other smaller libraries that help out with solving the mapping problem of I want to run a query and populate the struct. And my favorite, and the one that I have grown to love and use all over the place, is called SQLX. This is basically like general purpose like extensions to the database SQL package. So the thing that sold me on this was I'd written a whole bunch of code using database SQL, but I wanted to like stop having to scan all of this stuff. And SQLX basically provides its own, database object, its own rows object, its own transaction object. each one of those embed a database SQL equivalent. So like if you need to work with like code that you've already written like 6 months ago or a year ago or whatever, you can just basically pull out the real SQL.db and pass it into a function or something. So it was really easy to get started like going forward without having to go and like rewrite or hack apart a whole bunch of crap that I already done. So the types of additional scanning that it gives you is you can use struct tags. So similar to like with marshalling data with JSON. You can do the similar thing with the DB struct tags to say this field is actually named whatever in the database. And it'll just straight up struct scan a row into the object or into your structure. You can also do it if you are doing like a bunch of weird dynamic query building stuff. You can have it scan straight to maps. So you can get like a map with the keys being maybe like a slice of maps where each key refers to the column. So that I've used that before. Works out pretty well. And then you can also use it to just give you back like a plain like slice of interfaces, which would be equivalent to like with the Python database. Another really nice thing that it gives is a select routine, or select method, and that it hides all of the boilerplate for executable query. You give it like I want to select and pass in the query, and then you just give it like a pointer to like a slice that you want populated. And it's like, oh, you gave me a slice of foods. Like I'm just going to go ahead and do all the iteration and like load you up a slice of foods, which is pretty handy because for me, it removed the boilerplate, and that was like what I started getting like angry having. Another thing, some of the queries that I was showing earlier, the parameterization is based on your driver. So if you're using Postgres, you are parameterizing your queries by putting $1, $2, $3, and when you're doing your query building, you actually have to like take into account like how many parameters am I passing in up until this point? Okay, now I'm passing in my 8th parameter, so that is $8. SQLX supports query rebinding, which means you can use like the question mark style, like MySQL parameterization. And at the end, before you execute the function, you can say SQLX.rebind, and SQLX knows what driver you're using, and it will say, question marks, and Postgres doesn't support that, so I'll go ahead and $sign all of them for you. That was another really nice quality of life thing, because we use Postgres a ton, and query building $sign stuff was getting it a bit old. And then the last thing is that it also supports executing name statements. So again, back to the struct tags, you can say this field is named my food field 123, and you can actually reference it in your query by like the name of the field in your struct. So if you don't want to do the $sign or the normal parameterization of your queries, you can straight up give it names of fields in the struct. When you execute your statement, you just give it that struct object. It'll populate it. So for me, I use that a lot with inserting data because there's nothing more annoying than adding or removing columns from the table and having to go in after the fact and update your struct, and then also update the positional arguments to execute function to insert the data. In this case, you just write it, reference the name of the struct, you can reorder them, and then you don't have to spend a ton of time figuring out why your query is needed. So to get into that struct scan, for example, before I had a whole bunch of lines where it's like, query, defer rows closed, for rows.next, all of that other stuff. And then we'd say, all right, here's my slice of foods. And execute that query and populate foods, and you're done. So, that's pretty awesome. It's using reflection for everything. So if you hate reflection, you can use this. But basically, all of the struct mapping stuff. It's not there right now. Their equivalents. So for the query row, if you use the db.queryx, it will return a SQL X rows object that gives you access to struct scan, map scan, slice scan. And then there's an equivalent to query row that is called get, which works identical to this. If you're selecting a single row, you can just say select into single food object. So for modeling data, talked a little bit before about you can use map scan if you want to be lazy and not necessarily tie your data to structs all over the place. The rows object, when you're iterating over a query response, it does provide you a list of columns that come back. So if you don't want to use SQLX, what I used before SQLX is I would iterate over the columns to build up my maps. But if we actually want to kind of do more idiomatic Go, then we need all of this stuff in the database into our structs. So databases have these things called nulls, and what do you do about that in Go? What is a null integer in like a struct? Like, what does that even mean? So it could mean that you have like a pointer to an integer in your struct, and then every time you want to do anything with it, you have to reference it. Or you could use the some of the null types that the SQL package provides for you. So this is all part of database SQL, so it's part of the standard library. It gives you nullable types for bools, floats, and integers. And the way it works really is you check the valid property to see if it's set or not. Valid false means there's a null object. Valid true means you have a result. And that's it. They don't implement the JSON marshaller or unmarshaled functions. So if you're expecting to be able to run a query using null string, null int, whatever, and then just like JSON marshal that thing straight out like a REST API you've written, you're going to end up with something like this, which so you basically have to embed it and define your unmarshaled functions.
Somebody's written a nifty package that embeds these into one that implements the JSON stuff. So.
Well, I have like, yeah.
It's fairly straightforward, but it's nice if you haven't done it already to go grab it.
Yeah, which you have.
If I had a network connection, I'd look at that.
Anyway, so that was something that was like, oh man, cool, I can use nulls.
Might have it on my machine.
It's like laziness as a virtue. There will be someone.
I'll see if I can pull it out of my Go path.
So one of the things that people recommend, so if you're interacting with like a legacy database and like uses nulls all over the place, like you're gonna have to use some kind of like null representation. But if you kind of like get to have your say and you're okay not doing like idiomatic like databasey things, being like if you can use the default like 0 values for the Go types to represent a null in the database, then that's like it can be a lot better than having to deal with these null star types all over the place. Specifically like times and stuff like that. Like you can actually store a time.
I'll write down.
The other thing would be, and what I use a lot is I'll create intermediate objects. So I'll say, here's my kind of intermediate, this is my database representation of what a foo is. And I'm going to run my select statement into this guy. So like this is like, oh yeah, this could be a null string here. But then what you actually return is you do whatever massaging you need to turn that into your Go object. Downside with this is that for a lot of your queries, you potentially end up with like, you know, you have like 2 struct definitions for like everything you do. So here's how to get it out of the database. Here's what I want to work with later on. This is basically kind of
Somewhere for people to sit.
okay, yeah. This is kind of the, so if you're using Postgres has JSON column types. It's kind of the same thing. Like this is really just like a byte array that you're getting back here. Like later on in your code, you're probably not going to want to get data and set data every time you're like interacting with it and changing it. So you know, just find the multiple types and you know, unmarshal it into the proper, like whenever you're actually doing your query, you know, have the database representation being like, oh, I'm going to give you JSON data here, but then have the type you're actually returning be like, you know, an interface so you can use the standard like type switching. And then some other tricks. So you have these exec query and query functions. More than likely, like if you write a piece of code that is like, I want to, you know, get a food by ID. Like it'd be really nice if you could use that same piece of code in a transaction or not in a transaction. It's kind of like a little that kind of thing. So one of the first things I do is I'll just define like a SQLer or querier interface or something like that, which has the routines that you're actually going to use, whether it's SQLX or you know native database SQL stuff. And then instead of passing around the references to your database handle that you created, you can just pass this interface. And this interface is implemented by the transaction object and then the normal SQL object implement the same function signatures. So you can effectively, like in the query single food here, you know, you could pass in a transaction object, you can pass in just your normal database handle. It's going to query that food and give it back. The other thing is kind of standard for testing stuff, just use interfaces. Later on, testing. So I did not do too much in the testing stuff. But essentially, when I'm doing my data, I'll say like, here's my food store. And these are the routines I'm using to interact with the database, and I will test those to make sure that I did not factor in my SQL and all of that. But then later on in the guts where I'm actually like processing data and doing stuff with it, you can just use the interface and you can mock it out. You can force it to like return specific errors to make sure that like you can handle like not being able to save data or not be able to do that. You know, what happens when the data isn't there and it returns an error. It's just kind of the standard testing stuff. So overall, the things that I'm missing, I guess, from my Python life, I used to have some kind of like test data generation tools where you can define like, you know, I have my foo object. My foo object has an ID, it has a value stream, and it has a time associated with it. Being able to just like quickly produce a lot of like kind of randomly generated data that like fits into that is something that I miss quite a bit. There are packages for faking data. One's called Faker. But I feel like there's another step between having like something that can generate fake data and then something that can just like look at like, you know, reflectively the types of your struct and just like kind of figure it out for you. Like I think that would be pretty cool. And then there's also like ultimately I have like at the end of this I have like an interface to you know, like querying a database and doing stuff. And then I also have, you know, like my struct definitions of like my data. It seems like there's still, like, if you want to take this to like the next step and like REST API around it, there's still a lot of boilerplate you have to do to glue, like, oh, now I take in my query parameters and then I feed it into, you know, the list function, and then I, you know, marshal the results of that out to the caller. There's quite a bit of boilerplate there that I think could be just automatically generated. And I believe that is about it. So, are there any questions? I kind of just blew through that. Database SQL, don't be afraid of it.
All right, last and we're going to be talking about
Database.
hey, database deployments right after database is awesome.
Yeah, that's good. Perfectly timed.
Perfect time.
All right, everybody cross your fingers. I'm the only guy not on a MacBook, so.
Yeah.
So, okay. So I'm Ian. I'm here to talk to you about database deployments using Go. Unlike some of the other presenters tonight, mine's kind of like a three-part. First part is the story of how I got to Go. The second part of the story is how Go helped my team do database deployments. And then the third part is just me looking at my navel and thinking about, well, how'd that go? All right, so before we really get into it, a little bit about me. I am Ian Zucchero. I am a developer, database developer at the College Board, which is actually right back there at the back end of Preston Town Center. We're the folks responsible for the SAT and AP tests. So in advance or already, sorry about that. I'm a free software developer, and in my spare time, I hike. Just like I like to shave off CPU cycles and time, I like to shave ounces off of what's going on right now. All right, so I mentioned that this is about database deployments. So yeah, what exactly is that? So out in the industry, they're often called migrations. So anybody use like Django South or maybe Flyway DB. Anyway, so what it is you have your data store, and it's at a particular version. Let's just call it 1.0.0.0. And we do stuff to it. That's my big. We're going to do stuff, and it'll take that data store from version 0 to version 1. The secret sauce is what happens in that do stuff step. So at my company, do stuff includes data definition, so altering columns, modifying tables, defining stored procedures and packages, mainly in an Oracle environment. Data manipulations, that's where you're actually messing with the data in there and doing updates and selects. We also do a lot of loading processes. So you don't necessarily want to check in your 3 GB data load file into SVN or Git for repeated deployment. So you may want to just reach out to a local file system to leverage whatever tools your database provider gives you to load that data quickly and efficiently. So for Oracle, that's like SQL Loader, the classic import, or the slightly less classic import data pump. Okay, and lastly, we want the ability to be able to do procedure calls. So that involves doing anonymous procedures
or calling out to existing packages and procedures that we did stuff with earlier. Okay, so that's that middle step and the do stuff. So hopefully all the stuff I just said would impress upon everybody that we don't really want to do this manually. You really want to automate this. You want to remove human intervention from this process. You want something that's very repeatable, that will take your data set from version 0 to version 1 the same way, in the same order, every single time. So I think the subtext here is build a tool for it, which is what I did, what we did, or use one of the aforementioned tools if it works for you in your system. Okay, so let's talk about some of the goals there. I already mentioned a little bit about wanting to minimize human intervention, but it's also important for whatever package that is in that do stuff section to be easily interpretable by a human. You want to be able to open up a particular version or change set and see exactly what's going on. So it has to have a simple package or Delta format. So I already talked about it being repeatable. Also, I briefly touched on that. I don't want to reinvent the wheel here. So Oracle already provides me lots of utilities to load data transactionally or in bulk or through another database or whatever. Oracle provides a lot of tools, rich set of tools that I don't want to reinvent. Okay, and last but not least, satisfying auditing concerns. We want each of these builds to be traceable. So after you bring a data set from version 0 to version 1, you want to go and be able to examine, did I do what was expected to be done? So you want to be able to go back. That helps a lot later when it's 2 a.m. and one of your database builds failed and you want to know why. You're going to want to be able to figure out why through your logs and such. So in the beginning, there was Perl. I think that's a lot of stories start that way, right? In the beginning, there was a Perl script that we wrote. A coworker of mine wrote it maybe 10 years back. So it worked great. It worked great for a long time. But we had a dependency on having a Perl runtime. Every single environment where we wanted to do a deployment from had to have Perl there. Okay, so that's one thing. X in my book. Anybody ever write Perl? Anybody ever have to go back and read or rewrite the Perl that you touched a little bit earlier and kind of got a little gray hair, pull it out? Yeah. So we know how that is. So we want to try to get rid of that dependency on the interpreter. Lastly, this Perl script, every time we do a particular change set, it would stop and say, hey, are you ready to proceed? So what does that mean? If I'm doing a whole bunch of change sets for my desk, but I have a meeting right in the middle, I come back to a big fat question mark on my desk. I just have to hit enter, go to the next change set. If I have another meeting, well, too bad. And these change sets are going to take all day. So the combination of those things, being Perl, nobody wanted to go in and mess with it because, hey, it was working, and B, tolerable. So it stayed that way for almost 10 years. And it actually worked really well. I owe a lot to the former developer who wrote this stuff. So, and then our architecture changed. So way back in a couple of slides, I showed you just kind of one data store on the left, and then we're applying change set, and it goes to another data store on the right. Well, one database developer had a system, there it gives it away. It was my architecture that changed into something that looked more like this, right? So what we have here is, instead of just taking one source database, I remember about source databases from this, is we had to apply that change set to multiple data sets elsewhere. So in Oracle parlance, we have, we went from a one-to-one instance to now I'm going to say 8 different instances. So there's actually a much simpler architecture diagram than what I've had to deal with. So the same database change needs to be applied across multiple instances. I think you all can guess where I'm going with this. The old Perl tool, definitely not concurrent. Definitely ran each of these 8 instances in sequence. We had a concurrency problem. So fortunately, we know something that does concurrency really well. This is kind of where it gets, oh yeah, Golang will help you here. So I took it upon myself to write an entirely new tool, in Go, of course. If it wasn't in Go, I probably wouldn't be here. That did the concurrent deployment of change sets across multiple instances. And I was really annoyed at having to come back to my desk and click Y, enter, to do change sets. So that had to go. That was right out the door. More importantly and more tricky is backwards compatibility. So we had all these previous change sets that were applied by this Perl tool going back to before I even joined the company, right? Big problem. I gotta make sure it's backwards compatible so that if I suddenly switch over to this brand new tool, I can't lose the ability to deploy some of my old change sets. So I wanted the ability to completely go to this new tool and still, go vertically up and down my change set history with no issues. Also important to consider that since this application was the one that had the architecture change, it was my application, I wrote this tool just for me. So it was kind of liberating. It's not often that you get an opportunity where you're the sole person that has this problem and the opportunity, ability to go and change. So here's where we get into a little bit of the code sections. And this code is not obfuscated on purpose. I tried to keep it within the slide and also to protect some confidential stuff. So don't try to take this and compile it. But I tried my best to give you the gist of what we're doing. Okay, so the first major thing that helped was filepath.walk. So filepath.walk, I went to that one already, sorry. So you create this little walk function over here, and this basically takes in the path that it's looking at, some file information, and then an error. So what this enabled me to do is, instead of being in a specific directory where all of my change sets had to be co-located, so I'm now liberated from that. I can be anywhere up the hierarchy. So as it happened, our change sets happened to be cut at a directory level at like the major version point. So there were 4 numbers earlier. That's major, minor, point, patch, or patch point. And so we would cut the directories at the major version numbers. So by defining this little walk function, I could go up 2 directories, and I could suddenly get the feature almost for free of going across change sets. And so that's exactly what this is doing. So I have a regular expression defined elsewhere, which is my Delta configuration file. But if I find a file that matches that regular expression, I know I have a change set for one particular version, right? So I'm going to go and collect that and make some determinations of whether or not I want to include it. And if it's included, I just add it to this slice of config files. And I was really happy with how that worked out. Short, concise code, but it really liberated me to go across change sets in a way that we hadn't before. So this one should really come as no surprise. As soon as I said that we had a concurrency problem, I bet you all were thinking, okay, it's either going to be using something from the sync package or just channels, something like that. Well, sync wait group is what I went with. So basically what this allows me to do is I'm sitting in one, so picture I'm inside of one change set. I have a list of SQL files that I need to deploy, and I need to deploy them across 8 instances. So I do this by schema. And it's really nice because I know in advance how many schemas are going to be hit. So how many instances are going to be hit. It's going to be 8. So I'm defining my wait group here. I loop over the different connections that I have. So for every connection I have, I want to say, okay, is this the schema that I'm targeting for this particular SQL file? If so, I'm going to add a new member to, I don't know if they're called members or not, but a new guy to the wait group. And then I fire off this go routine. And in the go routine, I have an abstracted await and interface to the Oracle SQL Plus tool that just says, run me this SQL file. I'm able to get its status basically from the command package. And I'll either print, fail, or OK. I don't really need to know exactly what happened in terms of the error, so I'm doing nothing more than just incrementing an error counter to tell me if I need to bomb out or continue on. Okay, so once I've done all the work, I've actually called SQL Plus. My change is represented by the SQL file is complete the database, and the return comes back to me as successful. I tell the wait group that I'm done, and there you have it. So in effect, this is what this enables here. Let's see if I can come over here and zoom in. I know it's
Question real quick.
Could you go back a slide, please? I'm relatively new to Go programming, but is it not the case that with this disclosure, then the connection that you're getting might be that all your all your workers, or your folks, will use the same connection? Because if you loop relatively fast, because you're not passing the argument to the function or maybe closing over it.
It's actually one of the things I deleted to make this slide.
Oh, okay, fair enough.
But yeah, it's in there. We'll try to run this through. Probably bad things will happen. Yeah. But this does accept a parameter and some other things relevant to my environment that I just kind of snipped out. So my apologies about that. So let's have a look at what this enables. So again, these things are obfuscated a little bit to protect the innocent. Let's see if I can. Does that help? All right. So here we have this one foo.sql. Everybody loves to use foo, so I use foo. So foo.sql, we wanted to deploy that one to all connections that had a test schema configured. So, and then you see it's splaying those out to 8 different instances, and it's giving us some stats about that. The key thing here is that down at the bottom, so that 4.42 seconds, that would have been basically 8 times that. So now just imagine I have some scripts out there that are like 20 minutes. So if I had stayed with the Perl version, the sequential version, I'm dead in the water on deployment day. So this was just absolutely critical to staying alive.
Let me ask a really stupid question.
Sure.
I'm worried that I'm going to laugh at it. I'll give it a try. Why couldn't you just run the Perl script concurrently?
Why couldn't I run the Perl script concurrently? Well, this Perl script was written 10 years ago by somebody who wasn't me, very convoluted. And we don't have a lot of Perl resources available in the group anymore. But we actually have a good number of people who are at least aware of Go, and we have very proficient Java programmers. So, but to answer it more directly, this was my need. And I'm not going to modify the Perl script.
Well, you wouldn't have to. I mean, just run the Perl script concurrently by a handler.
Well, we still also had to change the directives around a little bit. So it had to be aware that this SQL file could be deployed concurrently. So, but the gist of it is, I had this problem. I saw that we had the ability to use Go. I wanted to use Go, and it ended up working out. But I'll talk a little bit more about that in a couple of slides. All right, so sort. Since everybody doesn't want to continually re-implement merge and quick sort for the rest of their lives, it's very nice that the sort package exists. This is probably pretty simple to everybody here, but you define your type, and you define a length, swap, and less function on it. And then hooray, you can call sort back sort, and then you get a sorted list or slice of that type of the top coming out. So why was this especially important? Well, if you recall back when I was talking about the walk function, we're 2 directories up. from a whole bunch of change sets. I don't want to go and have to collect it really helps to collect all of the applicable versions through one walk and then sort them semantically according to my custom type. And then I can do things like, instead of every developer DBA specifying a comma-separated list in order of what they wanted to deploy, I could do things like do a range, or I could do one-offs, or I could still do the set. Or if I leave things off altogether, I could grab them all. So that's kind of what sort helped me to do in here, is enable me to get these guys in the correct order, no matter which order they came in from the walk function, no matter which order they were collected by. Does that make sense, everybody? You don't want to be doing an update statement, setting a column when you actually haven't added a column yet. Okay, so trivial MD5 sums. This is something that we didn't have in the old Perl script. I just added it because it was nice for the traceability aspect of things. I thought it was very easy to get a nice little MD5 sum that would tell me, did I deploy what I intended to deploy? So we can go back to we actually use SVN, so we could actually go to SVN and look at the files and match those up. So if anybody comes back later and said, did you deploy this right version? And I can say, well, yeah, let's look in the logs, and we have the MD5, and then you can do an MD5 of what's in SVN for this change set, and then they should match. Okay, so that was a really nice additional thing to have. Now, this one's really simple. Just having the flag package, what I found was super nice. So I could define all my things, and I'd get a help string by default, which helped. I'm in a group of about 25 developers, and you would not believe the variation in command line invocations that you would get from 25 developers. So it really helps to say, okay, you can run it without anything, or you can give it with a leading dash. You can put an equal sign in there, flag handles it. But I particularly like the nice little help text, which you can override and stuff, but I didn't. Okay, so little gazing up at the sky on adoption. I think if I were to say one critical thing about success, is just it existed. So I just started small. I worried about my own application, and I trusted that my own pain points would be shared across the whole team. And fortunately, they were. So it's not like I made this tool and I socialized the heck out of it. It was basically like, oh, hey, Ant, I noticed your deployments were 5 minutes instead of last release. They were like an hour. I remember you were on the phone at 2 a.m. Forever. What happened? So, yeah, all right, step into my cubicle, step into my office, we'll talk about it. And so it kind of spread virally from there. I was pretty opinionated about changes to how the old tool would behave. That was another selling point, was I wanted to, at the same time, avoid a lot of this manual intervention, but I also made some decisions about doing hard errors that the previous developer didn't want to do. As a result of that, we flushed out a lot of issues in older change sets, which is ugly because these change sets are already in production for quite some time, but it's the nature of the beast. So binaries. I mentioned earlier about being chained to the Perl interpreter. What I didn't mention is that the Perl interpreter that we're using is chained to our ticketing tool system. Anybody use the Rational suite of tools? ClearCase, ClearQuest. It comes with a Perl interpreter. That was the Perl interpreter we were using. So that's not bad as long as we're chained to ClearQuest forever, but we're already taking steps away from that. So it was already immediately apparent. It's a bus that's coming. It's a couple of miles away, but that bus is coming when we can't rely on having a Perl interpreter there always for free. Suddenly it could become a production operations problem of, oh crap, we don't have licenses for ClearQuest anymore. And I'm going to have to go and install all of these across my enterprise. So that was the binary aspect helped a lot more than I envisioned, and our Unix guys really appreciated having just a binary that we could build on Linux and on Windows, which does constrain me a little bit. All this tool was written just using the standard library. And so lastly, I think the biggest factor in success is just cautious forward progress. So after the cat was out of the bag and all these 25 developers are banging on the tool, we let it go for seriously like 4 months longer than we expected, than it was really needed. So every development production DBA was involved, and critical change, let there be bugs. There's going to be bugs in there, but we handled that with our normal bug tracking systems. And then we checked this into source control. So the previous tool was just a file that was sitting on a network share that had write access to everybody. See, so some of you guys are laughing, some of you are cringing, but yeah, I think you get my point there. So source control for the win. So all this stuff is change tracked and bug managed. It runs faster, all because Go really helps. So that's all I got for you guys. Any questions?
Did you do anything to schedule the updates, like so you didn't hit one database server concurrently too much?
I didn't have to do that, just because the way our architecture is we have basically a dedicated set of development DBAs who are working on the change sets. And so if we had stuff that would conflict, it was enforced to be sequential to get the change sets. So all the tap dancing around any of those collisions are basically at the interpersonal level, operational level.